So you've spent all this time designing your study, collecting your data, and building that PLS-SEM model. But now coming the big question, how do you know if it's actually any good? Well, this right here is your practical, step-by-step checklist to find out for sure.
Okay, let's dive right in. This is the core question, isn't it? Every researcher hits this point. You've got this model sitting in front of you, but can you trust it? Is it robust? Let's walk through the exact metrics you need to check so you can answer that question with total confidence.
First things first, before we can even think about testing the cool relationships in your model, we have to inspect the building blocks. This whole first step is about the measurement model, making sure your survey questions and your concepts are solid, reliable, and are actually measuring what you think they are.
First up is internal consistency. So think about it. For a single concept like customer satisfaction, you probably have a few different questions. Do those questions all hang together? Are they all pointing in the same direction, consistently measuring that one idea? We've got two key ways to check this.
All right, so you've got two main tools here. Cronbach Alpha is the classic, the one everyone's heard of, but the more modern and frankly better choice is Composite Reliability, or CR. Now for both, you're shooting for a score of 0.7 or higher, but CR is generally considered the more accurate and robust measure.
Next, we need to check for convergent validity. What this really asks is, do your questions for a single concept truly converge on that one idea? Do they really represent it well? The metric we use for this is the average variance extracted, or AVE.
And the magic number here is 0.5 or greater. Hitting this means that, on average, your concept is explaining more than half of the variance in its own questions. It's a super important checkmark that tells you your measures are really zeroing in on the right idea.
So your concepts are consistent and they're well represented. Awesome. But are they actually different from each other? I mean, you don't want your brand loyalty concept to basically be the same thing as your purchase intention concept, right? They need to be distinct. That's where discriminant validity and the HTMT ratio come into play.
For the HTMT ratio, the number you want to see is a value below 0.85. Think of it like this. You need to have enough clear daylight between your concepts. If that number starts creeping up, it's a huge warning sign that two of your concepts might be overlapping way too much.
We've looked at our concepts as a whole. Now, let's zoom in and get granular. Let's look at the individual questions themselves, the indicators. How much does each specific question really contribute to the main concept? We find that out by checking the outer loadings.
Ideally, you're looking for an outer loading of 0.7 or higher. When you see that, you can be really confident that an individual question is pulling its weight and is strongly connected to the concept it's supposed to be measuring.
All right, the foundation is solid. Our building blocks are good to go. Now, we get to move on to the really fun part, evaluating the structural model itself. This is where the story starts to unfold, where we test the relationships and the predictive power you've been thinking about all this time. But first, a quick health check. When you have a few different things predicting an outcome, you have to make sure they aren't redundant. Are they actually telling you different things, or are they just echoes of each other? We check for this, it's called multicollinearity, using the VIF. The variance inflation factor, or VIF, needs to be below 5. That's the guidance from leading researchers like Hare and his colleagues. Keeping it under 5 ensures that each of your predictors is making its own unique contribution to your model. Okay, now for one of the big ones, R-squared. This is basically your model's report card. It tells you exactly what percentage of the change in your outcome variable is actually explained by all the predictor variables you've put into your model. It's all about explanatory power. And we've got some pretty standard rules of thumb here. An R-squared around 0.25 is generally considered weak. If you hit 0.50, you're in the medium range. And if you get up to 0.75, well, now you're talking. That's a strong model. Explaining things is great, but predicting things? That's even better. That's what predictive relevance, measured by Q-squared, is all about. It tests whether your model can accurately predict new data points that it's never seen before. And the rule here is super simple, but it is absolutely non-negotiable. Your Q-squared value must be greater than 0. If it's not, your model has no predictive power. End of story. Even a high R-squared doesn't matter if you fail this test. Okay, time to zoom out again and look at the whole shebang. How well does the model you came up with, in theory, actually match the real-world data you collected? The standardized root mean square residual, or SMRR, gives us a single number to judge that overall fit.
For a good fit, you're aiming for an SRM-R value of less than 0.08. Getting under that threshold is a great sign that the discrepancy between your theory and the actual data is acceptably small. Your model is a good representation of reality.
Last but not least, we want to know about impact. It's not enough to know if a variable has an effect. We need to know how much of an effect it has. That's where effect size, or F squared, comes in. It tells you the practical significance of each specific relationship.
And just like our other metrics, we've got some handy benchmarks. An F squared of 0.02 is a small effect. 0.15 is considered medium, and if you see a value of 0.35 or higher, you've found a large, really substantial effect.
Okay, let's pull all of this together. And just a quick heads up, you might hear about an older metric called goodness of fit, or GUF. The modern consensus is that it's not really recommended anymore, so it's best to just stick to these core, robust metrics we've just covered. And here it is, the golden checklist. This is the slide to pause, take a screenshot of, and keep by your side. It summarizes every single key metric, what it's for, and the critical threshold you need to hit for a truly rock-solid PLS-SEM model.
Look, passing all these technical checks is absolutely crucial. It's what gives your research credibility. But it's not the finish line. The next step, that's the most exciting part. Because now that you know your model is reliable and valid, you can finally ask, what is the incredible story your data is just waiting to tell?